Today we're going to talk about pH and pOH, and you should have just watched the rainbow tube demonstration. That demonstration showed you a green solution that was water with universal indicator. Universal indicator's green at a neutral pH. And then to one end of the glass tube, hydrochloric acid was added, and then to the other end, a base, sodium hydroxide, was added. And when they were mixed, what you saw was a rainbow, and that is the color seen at different pH values across the entire pH scale. So here's a picture of a pH scale. It shows you on the left, to the left are acidic substances, to the right are alkaline or basic substances. Some of these are everyday items you may use. Batteries, lemons are what we use to describe the properties of acids last week. If you drink soda or coffee, those are all acidic. Water is neutral. And then on the right-hand side, you can see there are cleaners like bleach and soap. Those are basic. Stomach tablets would be your antacids. So the milk of magnesia demo from last week, milk of magnesia contains magnesium hydroxide, and that's basic. So we're going to talk about the pH scale, and we're going to do calculations with the pH scale today, and also talk about the pOH scale. So pH is French for the power of hydrogen. And so the equation we use for pH is that it equals the negative log of the hydronium ion concentration. And yesterday we went over how to calculate hydronium ion concentration if you have hydroxide ion concentration. And so we will go over more calculations today. You can also rearrange this scale, this to be hydronium ion concentration equals 10 to the negative pH. And so the pH scale is from 0 to 14. A pH less than 7 is acidic. A pH equal to 7 is neutral. And a pH greater than 7 is basic. And so pH is related to powers of 10. So if I have a change in pH of 1 unit, let's say I go from a pH of 5 to a pH of 4, so I'm going to a more acidic pH, I have a 10 times increase in the concentration of hydronium ions. And so pH is a logarithmic value, so there is a new sig fig rule. And this applies to pH and pOH. For pH, So pH is a logarithmic value. Only digits to the right of the decimal point are significant. And so, for example, if I have a pH equal to 10.26, this only has 2 sig figs. Those are the only significant digits. This only applies to pOH and pH. And so I'll go over it again when we get to pOH, but they're logarithmic values. And so only the digits to the right of the decimal point are significant. So if we have a pH scale, which tells us the hydronium ion concentration, we can also look at this in terms of pOH. And so pOH is based on the concentration of hydroxide ions. And so I have both scales here. For P, this side is acidic. This is basic. And so for the pOH scale, it's 0 to 14. A pOH less than 7 is basic. A pOH equal to 7 is neutral. And a pOH greater than 7 is acidic. And so pOH equals the negative log of the hydroxide ion concentration. We can also rearrange that to say that the hydroxide ion concentration equals 10 to the negative pOH. And so if you have a change in one pOH unit, it is equal to a 10 times change in the concentration of hydroxide ions. Okay, so just like pOH, or just like pH, pOH is a logarithmic value. So only digits to the right of the decimal point are significant. So for example, if I have a pOH equal to 4.321, only these digits are significant, so it has 3 sig figs. So what we're going to do now is go through some calculations. I'm going to show you the graphic organizer we started yesterday, and we're going to add to that, and then I'm going to do a set of calculations and then have you do a set of calculations. If you don't have a calculator, you need to get one. And so if we need to pause the video while everybody gets a calculator, please do that. And you cannot use your cell phone because you're going to need to use scientific notation. You're going to need to use log values. So you need a scientific calculator. And I would like to remind you that you need to use the class calculators on your test and on your finals. So that might be the best thing for you to grab. So yesterday we went over hydronium ion concentration to hydroxide ion concentration. And we know from yesterday that we can use Kw, hydronium ion concentration, times the hydroxide ion concentration equals 1.0 times 10 to the negative 14th. So now we're going to add in pH and pOH. So pH deals with hydronium, so I'm going to put that on the left side over here. pOH deals with hydroxide. And so we're going to go through and relate all of these so you can use this to move from pH to hydronium to hydroxide or hydroxide to pOH to pH. We're going to go through all the different relationships here. So the first one I'm going to do here that we didn't talk about yet, but if you look at the pH scale and the pOH scale, they're both from 0 to 14. If the pH is 7 or the pOH is 7, then it's neutral. So if you have the pH plus the pOH, that will equal 14. So if I know the pOH of a solution, I can take 14.00 minus the pOH and get the pH, or vice versa. If I know the hydronium ion concentration, then I can calculate the pH, because the pH equals the negative log of the hydronium ion concentration. My arrow. So if I know hydronium, I can use that to find the pH. If I know pH, I can use that to find hydronium, because the hydronium ion concentration equals 10 to the negative pH. If I know the hydroxide ion concentration, let me write the equation. Well, let's do this. If I know the hydroxide ion concentration, I can find the pOH because that's equal to the negative log of the hydroxide ion concentration. And if I know my pOH, I can find hydroxide. And so we can use these relationships if you're given one value. If I give you pOH, you can solve for the other three. So as long as you're given one, you can find all of the other three, and that's what you're going to need to do. That's what we're going to do today in this video, and I'll have you one to practice. And then it's what you're going to do on your review guide you received yesterday, and then you'll have this on your test next Monday also. It's very important when you do these calculations, you show your work, because there is more than one way to solve the problems in different orders. And so you have to show your work so we know what you did. And we should still all get the same answer, maybe slightly different sig figs depending on which direction you went, but we should all get the same answer. So we're going to go on to the first problem. So this example, we're going to do A together. I have a pH of 9.28. From that, I'm going to find the hydronium ion concentration, the hydroxide ion concentration, and the pOH. So I have a solution with a pH of 9.28. So if I kind of go back to my graphic organizer, my pH is 9.28. So I'm going to go up here. And I'm going to start here on my graphic organizer, and I'm going to go over and calculate pOH. Simple. You have to write your equation. You're using pH plus pOH equals 14. Plug in my pH, 9.28, plus the pOH equals 14. And so when you subtract for sig figs, it's the least number of places to the right of the decimal point. So I have 2 places behind the decimal point for both of these numbers. So my answer is 4.72. pH and pOH do not have units. So looking back at my graphic organizer, I solved pOH. Now I'm going to use my pH, and I'm going to find hydronium ion concentration. Because I have my pH, I can use this expression over here in the red to find hydronium. So again, write what you're doing. Hydronium ion concentration equals 10 to the negative pH. So hydronium ion concentration equals 10 to the negative 9.28. And so on your calculator, if you have your calculator in front of you, you are going to hit the second button and then log. And so it should give you a 10, a caret, open parentheses. You type in negative 9.28 and you close the parentheses. Again, to solve this, you hit second, log, and then you'll plug in negative 9.28. For this problem, there are 2 sig figs. Remember our pH rule. This is only 2 sig figs. And so my hydronium ion concentration, and your calculator should be in scientific notation, it's 5.2 times 10 to the negative 10th. It's a concentration, so it's molar. So we have, and I'm going to move this over a little bit so I can write in the next box. So we have to solve for the hydroxide ion concentration. I'm going to go back to our graphic organizer. I have options here. So I have the pOH. I could go that direction. I could go pOH and follow the green route to find pOH. I could go from hydronium and use Kw to find hydroxide. So you have two options what you want to do. I'm going to use the Kw at the top to solve for hydroxide, what we did yesterday. And again, that's your choice. I'm just showing you different ways to go about this. And so I just found the hydronium ion concentration as 5.2 times 10 to the negative 10th molar. And so when I solve for my hydroxide ion concentration, that would be 1.0 times 10 to the negative 14th divided by 5.2 times 10 to the negative 10th. And so I would need 2 sig figs. The least number of sig figs when you're dividing is the rule. And it is a concentration. So what I want you to do now is for solution B, we have a hydroxide ion concentration of 3.02 times 10 to the negative third molar. I want you to find the hydronium ion concentration, the pH, and the pOH. Once you find those three, I want you to share with someone around you, and then to make sure you guys agree. And so pause the video. We'll take about 6 to 8 minutes to do these three problems, and then you'll come back to the video and I'll go over the correct answer. So pause the video, complete solution B for hydronium, pH, and pOH. Okay, so you should have calculated the three values that are left for solution B. I'm just going to write them here so we remember what we're doing. This would be, this one's hydroxide, this one's hydronium, this is pH, and this is pOH. So we have the hydroxide ion concentration. We need to find the other values. So I'm going to find hydronium first. I'm going to do Kw, hydronium ion concentration times hydroxide ion concentration equals Kw, 1.0 times 10 to the negative 14th. I will say that you may have gone in a different order. You may have used a different equation, but your answer at the end should match my answer. And so when you do this, you have 2 sig figs from the Kw. You have 3 sig figs from the hydroxide ion concentration. So your answer should have 2 sig figs. We go with the least number. And so that's your hydronium ion concentration. Next, I'm going to solve for pOH. I'm going to use my hydroxide ion concentration. pOH equals the negative log of the hydroxide ion concentration. So pOH equals the negative log of 3.02 times 10 to the negative third molar. The log button is on the left-hand side, the second row. And so you're going to hit negative log and then type in your value. And so for sig figs, because we got to remember our new sig fig rule, this is 3 sig figs. And so when we write our pOH value, the digits to the right are 3 sig figs. So I would get 2.520. And these are my sig figs. And then I need to find pH, so I'm going to use my relationship between pH and pOH to solve this. And so when you subtract, when you add or subtract, it's the least number of places behind the decimal point for sig figs. So I should have 2 places behind the decimal point. So you get a pH of 11.48. So on your chapter 14-15 review guide that you received yesterday, you have a set of problems to do for these calculations. I would work on those today if there's time left in class, or work on the rest of the review guide. We have one more topic that we will cover tomorrow, including titrations. You will have a lab this week that you'll do with Mrs. Barnett on Friday. And we'll be reviewing this week, and then your test is next Monday. The next 2 slides in the PowerPoint will go over those reminders and go over reminding you what finals or what will happen with finals next week. If you have any questions, please message Mrs. Chapman in Schoology or stop by room 335. Have a great day.